Hello and welcome to another math video. Today we're looking at linear inequalities in one variable. A few different things we want to be able to do. Solve linear inequalities using a couple different properties and solve applied problems using linear inequalities. Do want to start first off with some different notation in case you're not familiar. So in set notation, just kind of a fancy way of showing that x is greater than a or a is less than x. Graphically, again, we use the parenthesis at a, shows it goes up towards infinity. So in interval notation, we have parenthesis and then a to show the lower limit, and then going up to infinity. If we have compound inequality where a is less than x and x is less than b, then graphically we have a parenthesis at a and a parenthesis at b and cover the area in between. Interval notation, we go just a to b with parentheses there. If x is less than b, then we go negative infinity to b. Again, you can see the parenthesis at b to show where the upper limit is, and then goes everywhere below there. Here's just all real numbers, what that looks like. If x is greater than or equal to a, or a is less than or equal to x, again, notice the square bracket at a. Again, that shows that that value is included in going up. So we match that in the interval notation, the square bracket at a going up to infinity. Again, notice the infinity will have a parenthesis even though the a has the bracket. Here's another good example where a is less than x, which is less than or equal to b. So the a has a parenthesis, the b has the bracket. We can see the same thing on the graph, parenthesis there at a, bracket here at b. We can flip that around and get the a less than or equal to x less than b, and you can see how that changes. If x is less than or equal to b, again, just a little bit different there with the bracket compared to before. And then at the bottom there, a is less than or equal to x less than or equal to b. So we have brackets on both ends there from a to b. So again, just hopefully helping out there with understanding some interval notation. So we're going to focus on solving these inequalities. We do want to write the answers in interval notation and also graph them. So starting with example 1 here, we would want to add 7 to both sides of the inequality. We would end up with x is less than negative 5. So I like to do the graph first, after we get the solution anyhow. So if I put my negative 5 here, I'm going to change color so it's easy to see. So x is less than negative 5, so that would be going to the left. So we point the parenthesis that way. From there, again, I can see a little bit easier what the interval notation will look like. So again, here's my interval notation, and then we've got our graph as well. Same sort of process here. Not a whole lot of choice, but just deciding to subtract the 2m from both sides. So we get 14 is less than or equal to m. If you wanted to flip that around, you could. M is greater than or equal to 14. Either way is fine. Again, if we look at the graph, I'm just going to put 14 here. Greater than or equal to, so that means we'll have a bracket at 14, and then it would go to the right. Again, based on that, we can see the interval notation starting from 14 going up to infinity. One caution here, again, we have to remember to reverse the direction of the inequality symbol when multiplying or dividing each side in the inequality by a negative number. So solving these, again, not much choice here, we just divide by 5. I want to emphasize here, we're dividing a negative 30, but we're dividing by a positive 5. So m has to be less than or equal to negative 6. We do not flip the inequality there because we're dividing by a positive. The fact that it's a negative 30 doesn't have anything to do with flipping or not. The fact that it is a positive 5 means we do not flip. Same thing, we'll want to graph here and do the interval notation. So if I've got my negative 6 there, so less than or equal to negative 6, so it would go this way, just like that. Now the next example, I'm going to be careful how I do this. So we have negative 4k is less than or equal to 32. So really we want to divide both sides by negative 4. And notice how I resisted the urge to write that inequality in there already, because really as soon as we divide by that -4, that inequality flips. So you want to be careful about your notation there and how you're keeping track of things. You just be a little bit more precise about how you write that. This does simplify down to just be k is greater than or equal to -8, which then on the number line, put the -8 here. Let's see, greater than or equal to, so that would go this way. The interval notation then again pretty well lines up with the graph. We have a -8 on the left going up towards positive infinity. Solving this one, we do have a little bit of distribution to do on this problem. So we would start there. Distributing in, we get -3x minus 12. And it's important to make sure that that negative gets distributed along with the 3. On the left side, I can combine the 12 and the 2, -12 and 2. So we get -10. From here, again, it's up to us to decide which side we want the variables on. And this goes back to, again, my practice of always dealing with the variables first and wanting them to be positive. That way we can avoid situations like having to divide by a negative and flip that inequality. So just one more good reason to take care of the variables first and make sure that they will become positive. From here, there's not much choice. We would just subtract the 7. So I get -17 is greater than or equal to 2x. So it looks like we will get a fraction here, and I'm alright with sneaking that 2 in there because I'm dividing by a positive, so that will not flip the inequality. So -17 cut in half would be -8.5 is greater than or equal to x. And again, I'm okay with the -8.5 because that is exact. If you wanted to, you could flip that around. That's the same as x is less than or equal to -8.5. Number line could look like this. The -8.5 there. X is supposed to be less than or equal to that. So I have a bracket here, go to the left. The interval notation then goes towards -infinity, tops off at -8.5, so a bracket there. And so that's what we're looking at for those. Here we've got fractions to deal with, so again, one way we can do that is we can get rid of the fractions. The LCD of 2 and 3 is 6. So that LCD is 6. So really want to multiply both sides of the equation by 6. So if I do a 6 here, then I have -2/3, then r minus 3 minus the 1/2. And then the same thing here, we have our 6, and then multiply that by the 1/2, and the 5 minus r. Alright, so now we just need to distribute through those parentheses. So on the left here, it's going to multiply the -2/3, oops, not there, and it will multiply the -1/2. Again, notice the -2/3 times the r minus 3. Again, that's one part of our difference here, so that only gets multiplied once. Again, simplest way to do this is just to do -12/3 times r minus 3 minus 6/2. Same sort of thing here. This will distribute, or sorry, no, not distribute, it's just going to multiply the half because this is just one thing here. So 6/2 times the 5 minus r. And again, you're probably thinking, why didn't he just say 3? But we've got to take care of this anyhow. So -4 times the r minus 3 minus 3 less than 3 times 5 minus r. So we've gotten rid of all those fractions though, so that is nice. Now we just need to distribute and simplify, and we'll be just about ready to finish solving this one then. So at this point, distributing through, we get negative 4r plus 12 minus 3 is less than 15 minus 3r. The left side I can combine some like terms there. So combining the 12 and the minus 3, so I get plus 9 is less than 15 minus the 3r. So again, here I'm deciding between adding 4r or adding 3r. So I'm going to go ahead and add 4r. That will keep the r's positive, or make them positive, since they haven't been positive yet here. So I get 9 is less than 15 plus r. So we subtract the 15. And the 9 minus 15 is, of course, negative 6. And that's less than r. Again, if you want, you could flip that around. That's the same as r is greater than negative 6. Graphing that one, negative 6 here, greater than that negative 6 would go this direction. And of course, 0 is over here somewhere. So that's what the graph, the graph looks like. The interval notation, again, it's a parenthesis because the inequality does not have the equal to, and it goes from negative 6 up to infinity for that one. Just short caution at top there for a three-part inequality. The order of the parts is important. They are emphasizing here that it would not be good to say 8 is less than x plus 2, which is less than 3. Because then if you take out the middle, you really get 8 is less than 3, which is false. So you have to be careful with that. Notice in this one here, negative 2 is less than or equal to the negative 3k minus 1, which is less than or equal to 5. So negative 2 being less than 5, this works out just fine. So here we're going to solve the three-part inequality. What we want to do is focus on getting that variable by itself. So in order to do that, we would add 1 here. Because we're adding 1 there, then we also add 1 over here and over here, so to all three areas, left, middle, and right. That leaves us with negative 1 on the left, negative 3k in the middle, and 6 on the right. At this point, we would want to divide by negative 3. We would do that in all three areas, left, middle, and right. Since we are dividing by negative 3, we need to flip the inequality, and we end up with 1/3 is greater than k, which is greater than negative 2. And if you feel more comfortable flipping that around, that's perfectly fine. Just do a little flip there, and we get negative 2 less than k less than 1/3. The graph from that, negative 2 can be over here somewhere, 1/3 would be over here. We are greater than negative 2 but less than 1/3, so it's just the area in between those two. The interval notation then looks very much like the graph. It just goes from negative 2 up to 1/3, like that. Here we're going to be looking at using a linear inequality to solve a rental problem. Again, there's a little table here to look at just, again, the word expression and what that is for the inequality. So at least, A is at least B. We're talking A is greater than or equal to B. A is no less than B. We're looking at A is greater than or equal to B. So two ways of saying that same thing. A is at most B is A is less than or equal to B, and A is no more than B. We're looking A is less than or equal to B as well. So a few different ways to say those. Those can be helpful in case you're having trouble figuring out which inequality you should use. Here we're looking at the rental company. So $15 to rent a chainsaw, $2 plus $2 per hour. We've got Tom can spend no more than $35 to clear logs from his yard. what's the maximum amount of time that he can use the rented saw. So not more than $35. Let's see, so there's a fee of $15 plus $2 per hour, and no more than 35 can be spent. Well, so the cost looks like it's going to be just made up of the fee and the hourly rate. So if we do 15 for the fee plus 2, I'm going to use just H for hours. And that has to be no more than, so that's less than or equal to 35, like we see down here in our chart. And now it's just a matter of solving this, so we would subtract the 15 from both sides. Get 2H is less than or equal to 20. And dividing by the 2, we get H is less than or equal to 10. So to answer the original question, what is the maximum amount of time he can use the rented saw? So 10 hours would be the maximum time that he could use that rented saw. Here's a good example of a classic standardized test question. We've got Martha here. She's got scores so far of 88, 86, and 90 on her first 3 algebra tests. An average score of at least 90 will earn an A in the class. So what possible scores on her 4th test will earn her an A average? So let's see, so we've got scores of 88, 86, and 90 on those first 3. So if we were going to average those, we would just divide those by 3. Of course, what we're saying here is we've got a 4th test that we are looking at taking. So we're not going to divide by 3. What we're going to do is we're going to say, well, what is the score for that 4th test? Well, we don't know, so we're going to call it X. But that does give us 4 scores, so we divide by 4. And we want at least a 90 average. So the average, which is on the left, we want that to be greater than or equal to 90. So that gives us an inequality that we can set up and solve. We can begin by totaling the points that she has so far. So far Martha has earned 264 out of 300 points. Now at this point, what I would probably do would be to multiply both sides of this inequality by 4, multiplying by a positive number so that doesn't do anything to the inequality. When we do that, we get 264 plus x is greater than or equal to 360. And then what we need to do is just subtract the 264 from this 360, and we find out that x has to be greater than or equal to 96. And we're kind of assuming here, just with the numbers, that the test scores are probably out of 100, but greater than or equal to any score greater than or equal to 96 would earn her an A average. So that's really what we're looking at for that one. So yeah, again, make sure you always answer the question that is being asked, even if your teacher doesn't actually write it down. So yeah, hopefully this was helpful, and thank you for watching.